So the IVT is the last section that we're going to cover in the limits and continuity part of the course. I'm just going to read through the simplified version of the IVT. Right now it's probably really complex trying to read that definition. So a simplified version of the IVT is a continuous function has to pass through every y value between two known y values. And this will occur between two corresponding x values. So an example is in the picture here, let's just say that we know the two y values are f of a, and we also know f of b. This will occur between the corresponding x values a and b. So there is some value c in between a and b where I'm going to have an f of c. And I know that f of a is smaller than f of b, so f of c has to be smaller than f of a, or f of c has to be bigger than f of a and smaller than f of b. So a good example of this is if you're driving a car and you're going 70 kilometers per hour at 1 o'clock, 100 kilometers per hour at 2 o'clock, the IVT will guarantee that you have to travel 70 kilometers per hour somewhere in between 1 o'clock and 2 o'clock. Because to get from 50 to 100, you're going to have to pass through 70, guaranteed. But you can't go the other way around and say that at 1:30, you've been traveling between 50 and 100. Knowing that you're just traveling at 50 at 1 and 100 at 2 o'clock, you can't say that you've been traveling between 50 and 100 at 1:30. So the IVT only works in one direction. So if you're given a y between two known y values, you can be assured that there's an x between the two corresponding x values. But given an x between two x values, we can't be assured that there is a y between the corresponding y values. Here's an example of this picture here. Let's just say we're going to use f of x is equal to 25. And this will occur at least once, according to the IVT, between 1 and 5, because that's the interval that's given to us in the picture. But take a note that this f of 3 is not necessarily between 10 and 30. It actually goes beyond 30. Okay, so your f of 3 doesn't fit between our y values of 10 and 30. It actually goes beyond. So the IVT can say, we know that 25, which is our f of c in this case, sits between 10 and 30. So that means our value of c will sit in between the interval 1 to 5. But we can't say that because we know 3 sits in between 1 and 5, that f of 1 is smaller than f of 3, which is smaller than f of 5. Because look, f of 3 is actually larger than 30, because this would have been 10, and this would have been 30. We can't say that because we know 3 sits between 1 and 5, that our y value is going to sit between 10 and 30, because it doesn't in this picture. We actually have a y value larger than 30 here. So we can't go the other direction where we're using our y values to determine, or x values to determine our y values. You can only go from the y values to determine your x values. So here's another example. Consider the function f of x is equal to 1 over x on negative 2 to 2. And then this person checked the endpoints on the interval. And we're supposed to show that f of 0 sits in between there. Now, is this correct and a valid application of the IVT? Well, the thing is, can f of x ever be equal to 0? Can 1 over x ever be equal to 0? No, because we have a horizontal asymptote there. Or a vertical asymptote there, not horizontal, sorry. So what this means is that this whole thing is false. And this is not a valid application of the IVT because 1 over x is not a continuous function to begin with. And if you look at our definition here, f is continuous on AB. F is not continuous between -2 and 2. So we couldn't even use the IVT to begin with. It doesn't violate it, we just should have been using it. Because f is not continuous at x equals 0, which is on -2, 2. Here's another example. Is any real number exactly 1 less than its cube? What does this actually look like algebraically? This is x is equal to x cubed minus 1. So you want to show that this is true. Well, first you need to state let x be that number. And we're also going to let f of x be equal to this, but I have to make this into an actual equation that I can state as a function. So I'm going to move x to the other side. And this is what I'm going to get. So I'm going to state this as my f of x. X cubed minus x minus 1. And then we need to show that f of x is equal to 0. This is equal to 0, which is f of x. We can show that the f of x is equal to 0 using the IVT. So we need to pick some random endpoints here. So what interval are we going to use such that f of 0 and f of 2, maybe we could use those ones to show that our y values are in between 0. So f of 0, we could use f of 2. You could use the other numbers too. You don't have to use these. So if I plug a 0 in, I'm going to get -1. If I plug a 2 in, 2 cubed minus 2 minus 1 is 5. And look, 0 sits in between -1 and 5. So we also know f of x is a continuous function, and this is because this is a polynomial. So then by the IVT, there is a c such that this c sits in between our 0 and 2, where f of c is 0. And then we're done. So what we just did here, we actually used this as our guideline to use the IVT properly. The function is continuous on a closed interval. It's stated here that f of x is continuous. And you could also even add on 0, 2. The function values you're using that contain the desired y value. So that's over here. We plugged in our f of 0 and our f of 2, our endpoints into there to find out what the y values are. And we to show that the 0 sits in between those y values. And the 2 x values that correspond to the function values that you're using, which is what we've done there as well. And then finally we wrote the clear statement about the IVT. So we're going to do the same thing for example 3 and 4. We're going to use these 4 as our guideline to do these examples. So we want to show that f of x is equal to 9 somewhere. And we're going to use these as our guideline to do that. So we need to state that f is continuous because it's a polynomial. We also know what f of 0 is and f of 2 is. We're just going to do that calculation quickly. This is going to be 2, and this is going to be 16. So 9 sits in between 2 and 16. So what I did here is going to pick any number as long as f of x is greater than 9 and less than 9. Okay, so we can pick any number. It didn't have to be 0 or 2. We can pick other ones as long as 9 sits in between whatever you picked. So that was 2 and 3 here. And then lastly, we just state our clear statement by the IVT. There is a C in our interval such that f of c is going to be 9. Last one is the example is kind of like example 2. So we want to show this is true, that these are equal to each other. I'm just going to rearrange that. And I'm going to subtract the root of x minus 1 on both sides, and I'm now going to get this. So I'm going to call this my function. I'm going to show that f of x is going to be equal to 0. So show there's a f of c and it's equal to 0. Okay, so the first thing I'm going to state, one is that f is continuous, and you can verify this before you even begin, otherwise this would not be valid. Now we want to find f of 1 and f of 2. f of 1 is 1 minus root 2. This would be a negative number because root 2 is larger than 1. For f of 2, this is going to be a positive number. It's larger than 0. So 0 clearly sits in between f of 1 and f of 2. So state that. So f of 1 is smaller than 0, which is smaller than f of 2. Lastly, we're going to state our last statement about the IVT. There is a C in 1, 2 such that f of c is 0. And then we're done. Okay, so I have an IVT worksheet that I put into your homework on the OneNote. Please try to do those questions. I'm also going to write the answer key on there as well for you. Please try to look at these 4 different steps on how to do your IVT theorem. It's kind of your guideline on solving for all IVT questions, basically, because it's basically summarizes what we kind of stated up here, which is a more complex definition of it. But if you have any questions about it, please let me know. Send me an email, and I'll be happy to get back to you.